Fiber channel over Ethernet is a technology that allows us to do what we've been doing for years in the campus with voice over IP, where we've taken traditional telephone networks and traditional Ethernet data networks and combined them together so that both protocols run over the same wire and don't require separate network infrastructures. We're doing the same thing inside the data center with your storage and your Ethernet traffic, and that's called fiber channel over Ethernet. Now, in fiber channel over Ethernet configurations, there's multiple types of topologies that you might see. For instance, where you tend to get the most bang for your buck in consolidation and saving cost and saving in complexity and configuration in your data center is by converging the access layer, or the layer between the servers and that top of rack switch, or the first switch that they connect to. And in this case, what we're doing is we're taking devices that used to require multiple network adapters, both Ethernet and storage adapters, as well as Ethernet cables and fiber channel cables, and we're converging those to two high-speed 10 gigabit Ethernet connections. And we're allowing both protocols to run over the same network. We're able to do this in a way that we can actually separate out the fiber channel protocol from the Ethernet protocol. And we send it up to that top of rack switch, and at that point, that switch actually breaks out the protocols and sends the Ethernet, for instance, up and to the left, and the fiber channel up and to the right. In this case, we're actually dedicating a VLAN to send our FCoE traffic over. The server, for instance, sends the FCoE traffic in VLAN 30 on the right side, and it sends it in VLAN 20 on the left side. And that would be synonymous to SAN A and SAN B in a fiber channel environment. So we're able to give the server redundant paths to the storage that are highly available, and then we can maintain that through the Ethernet network. The host itself knows to tag the FCoE traffic as VLAN 30 and VLAN 20 and negotiates FCoE parameters between the switch and the host using the FIP protocol. In the host, we use a network adapter called a converged network adapter. And a converged network adapter is basically the same thing as my Ethernet adapter and my storage adapter, but they've been combined into one. So in a lot of cases, we use the same chipsets and the same drivers. And to the operating system, it actually looks like two separate physical devices that are plugged into that server, while it's really only one. So in your operating system, it may look like you have two network interface cards and two fiber channel adapters, when in reality, you only have one plugged into the device. The host still uses its same network interface drivers to control NIC teaming or failover, as well as the fact that the SAN still runs the same way it always has, using multipathing software to control which way we send the fiber channel information. In this case, we're actually connecting to two separate switches, so the Ethernet path will be active-passive, while the storage path will be active-active. It can be more of an optimal design to leverage what we call a multi-chassis ether channel through technology like virtual port channels that we'll cover in other lessons. But basically, the multi-chassis ether channel makes the two upstream switches look like a single switch, and therefore we don't get any spanning tree blocking on the ports connecting to the switch. This gives us network-based load sharing and redundancy without causing any types of loops in our environment. And we're still able to separate the SAN A traffic and the SAN B traffic on these switches to maintain the critical high availability of the fiber channel network. In order to support this type of configuration, we have to actually manually configure that SAN A will be using VLAN 20 on the left side, and SAN B will be using VLAN 30 on the right side. And VLAN 20 only exists on the switch on the left, and VLAN 30 only exists on the switch on the right. Therefore, we are manually configuring our SAN A and SAN B separation, and there's no way that the traffic can ever intersect. The other thing we want to do is configure our spanning port type edge trunk, and that allows the port to come up very quickly and negotiate all of the fit settings that we need to in between the switch and the host. The switches at the top of the rack have the intelligence built in to know not to share any of the fiber channel over Ethernet VLANs between each other, and therefore not to let these VLANs ever intersect with each other. We can also do what we would call multi-hop FCoE, or in other words, we can actually extend FCoE through other parts of our network. As I mentioned before, the most common place to see FCoE is at the access layer, but there are benefits to be had by extending FCoE into the rest of the network. For instance, a lot of times Ethernet cabling is cheaper than running fiber. There are also a lot of engineers that are very familiar with IP and Ethernet versus fiber channel. So extending that through the network can make a lot of sense in some cases. And we can do that a number of ways. We can do that by extending a fiber channel over Ethernet only connection, like you see on the right, where we can see that the host is actually sending both fiber channel over Ethernet and data up to the switch at the access layer. But between the access layer and the aggregation layer on the right, you can see that we break out the data into a separate VPC, and then we send the fiber channel over Ethernet traffic over a dedicated Ethernet link up to the SAN. That is a best practice recommendation for fiber channel over Ethernet and multi-hop configurations. We can also send the information, both fiber channel over Ethernet and data, over the same links to the switches northbound, but in this case we wouldn't use something like a VPC because we don't want the chance of SAN A and SAN B being able to cross paths. This type of configuration is called a unified wire configuration, versus the type of configuration on the right is called a unified fabric. The one on the left, we're sharing the same wire to run both Ethernet and fiber channel over Ethernet, whereas the one on the right, we're sharing the fabric, but we're not actually sharing the same links. So it's important to differentiate between those two terms. The reason that option 1 is a best practice over option 2 is the fact that we can actually separate out the two types of traffic. We get the benefit of using Ethernet as a lower cost medium and a more well-known technology, but we're able to take advantage for the data, for instance, of technologies like VPC to have that active-active path, as well as the fact that we're able to keep the data secure by having its own dedicated link that network engineers may or may not bring up and down at any time. We can also extend fiber channel over Ethernet down into the Nexus fabric extenders. The Nexus fabric extenders are a lower cost, more easily managed option that we sometimes call a remote line card. So my Nexus 2232 has the capability to support fiber channel over Ethernet. And if I choose to use that in my architecture, I can actually extend a lower cost model down to my access layer and allow you to take advantage of fiber channel over Ethernet. As I mentioned before, the FEXs actually act as a remote line card, for instance, to the Nexus 5000 series switches. So all the configuration is actually done in the Nexus 5000, and what we do in that case, once again, we say one of the 5000s is responsible for SAN A, and we say the second 5000 is responsible for SAN B. And that way, once again, we can manage our two redundant fabrics even across our Nexus fabric extenders, which in this case act like remote line cards. Even though this diagram doesn't depict it, we can also create a VPC between the Nexus 5000 and the 2232, as well as between the 2232 and the host. This is called enhanced VPC. Finally, we can extend FCoE all the way to the storage devices as well. Many storage devices in today's environment are coming with FCoE connectivity. In this case, once again, we can take advantage of a lower cost of cabling. In some cases, faster speeds, as 10 gig and 40 gig are faster than a lot of the fiber channel protocols out there today, as well as the fact that administrators still get access to the same services that they're used to. So for instance, all of the main fiber channel protocols are still used the same way they would be on a fiber channel network from end to end. but in this case, they're just encapsulated in Ethernet. Please join me for the next session, 16.2, Understanding Data Center Bridging.